Functional Groups by Aline Vo
and Natalie Oshesky.
What is a functional group? A functional group is an atom or group of atoms with characteristic chemical and physical properties. It serves as the reactive part of the molecule. So, for example, this is a template of a functional group, and it shows an R, which is a carbon skeleton bonded to the functional group.
Next are the structural features of functional groups. There are several structural features of functional groups, including heteroatoms, which are atoms other than carbon and hydrogen, and pi bonds that distinguish one organic molecule from another. These structural features determine a molecule's geometry, physical properties, and reactivity. Heteroatoms have lone pairs and create electron-deficient sites on carbon. Common heteroatoms include nitrogen, oxygen, sulfur, phosphorus, and the halogens, which are group 7 on the periodic table.
Pi bonds are easily broken in chemical reactions. A pi bond makes a molecule a base and a nucleophile. The most common pi bonds occur between carbon-carbon or carbon-oxygen double bonds. And these are just images that show what the previous slide was talking about. So you have the lone pairs that make the oxygen with the base and nucleophile, and then you also have the pi bond making up the compound base and nucleophile.
And here are some examples of other functional groups, and you can tell that they all vary in shape, which determine their physical properties.
So an example of a functional group would be the hydroxyl functional group within ethanol. And so you can see that it follows the same template that all functional groups follow, which is the carbon backbone. And then you have a functional group attached to the carbon backbone. So in this case, hydroxyl. And in hydroxyl, you have two lone pairs attached to the oxygen molecule. And you also have polar OH and CO bonds as well.
The most common functional groups are hydrocarbons, compounds containing C-Z sigma bonds, where Z is any electronegative element, and compounds containing a carbon-oxygen double bond group.
So one of these is hydrocarbons. And so hydrocarbons are compounds that are only made up of carbon and hydrogen. And they can either be aliphatic or aromatic, which we have provided examples of below, but you don't really need to know the details of this too much.
And here are some examples of compounds containing carbon-Z bonds, where Z is any electronegative atom.
So next we have compounds containing a carbon-oxygen double bond group. And so a CO double bond functional group is called a carbonyl group. And in this, the polar CO bond makes the carbonyl carbon an electrophile, while the lone pairs on the oxygen allow it to react as a nucleophile and base. And the carbonyl group also contains a pi bond that is more easily broken than a CO sigma bond. And so we have two examples of that. We have atenolol and donepezil. And you can see the functional groups in these two molecules.
The last group are compounds containing a carbon-oxygen double bond. These are just some more examples of those. And as you can tell, they all have different shapes, which help determine like what they treat and what they are used for.
And so we have a practice question. And so in this, we're just asking if you guys can identify the functional groups in ibuprofen. And we'll give you some time to figure that out.
And also, as you're trying to figure this out, remember the importance of functional groups. They help determine the bonding and shape, the type and strength of intermolecular forces in the molecule, the physical properties, nomenclature, and chemical reactivity. And here's the answer to that question. There is an alkyl group on that side, a phenyl group in the middle, and a carboxylic acid.
Thanks for watching. Thanks for watching.
Thanks for watching.